This will probably be a multi-part thing about how what Caleb thinks about spectroscopy and what science actually does. And sorry for the way it got captured. I just kind of learning how to use the capturing software at the time, so, and how to align it so you get only the top half of Caleb's base turn part of it. So, okay, thank you. Let's get on to it.
Have you ever heard NASA or other space agencies claim to discover that there's water on planets light years away, or that Uranus's atmosphere smells like farts? Yeah, NASA actually said that. Let's talk about the pseudoscience that is spectroscopy, in which they're supposedly figuring these things out. Spectroscopy is the field of study that measures and interprets the electromagnetic spectra that result from the interaction between electromagnetic radiation and matter as a function of the wavelength or frequency of the radiation. In simpler terms, spectroscopy is the precise study of color as generalized from visible light to all bands of the electromagnetic spectrum.
This is the electromagnetic spectrum. You notice that on the far left there's gamma rays and X-rays. These are and ultraviolet rays. These are very short wavelength rays. They're very highly energetic. And then you have the visible spectrum, which is just a small sliver of the entire electromagnetic spectrum. Then you have infrared and radio, and the TV is actually part of the radio, but those are very long wavelengths, like meters or kilometers long. So that's what it actually looks like. Okay. This is the solar spectrum. And you notice that there's a lot of dark spots in the solar spectrum. This is because there's 3 rules that come up called Kirchhoff's laws. Kirchhoff was a scientist in the 1800s, 19th century. And 2 of the laws that apply here, there's a continuous spectrum because there's a hot, bright object in the back, and that's the sun. And then you have an absorption of by the molecules and atoms between us and the sun. It's all atoms because the sun's hot enough and you notice all those little lines. We'll come back to it later, but this is the kind of stuff that they actually see. And then plus the next image will also show you what the scientists actually see, which is okay, just wait a second here. This is an actual, like, how much light is absorbed, or like you see these valleys, and that actually can give you how much abundances are in the sun. Okay, this will be the end of this part. I've got to keep it short because a lot of these algorithms like short content, but we'll have another bit in a few minutes here. I'll work on that. But have a good day, and I hope you enjoyed this. And it was informative. Bye.